All right, concept 5, finding real roots of polynomial equations. We're figuring out what are the values of x that make that equation equal to 0. In other words, what are the values of x that, or where are the points of the graph that cross the x-axis? That's what another reason we can do. Okay, so this first method, we're going to learn a couple different methods, and then we're going to combine this with the next concept, which is the fundamental theorem of algebra. So we're going to do 5 and 6 together because they kind of go together. All right, so let's do some conceptual stuff first. So zeros are the points at which the functions intersect the x-axis. I just said that. Okay. So a polynomial function of degree n can have at most n real zeros. It can have up to the degree of that many zeros. It can hit the x-axis up to that many times. It doesn't have to hit it that many times, but it can hit it up to that many. Okay. An even degree polynomial has an even number of zeros, or no zeros at all, and an odd degree polynomial has an odd number of zeros. Okay? All right, so let's do an example. Solve the polynomial equation by factoring 3x to the 5th plus 18x to the 4th plus 27x cubed equals 0. So remember, from the last concept, we want to find a GCF first. Okay? Excuse me. So what can I take out of everything right away? There's a couple things. All of these are multiples of 3. So I'm going to divide everything by 3. Okay? Actually, I'm not even going to do that. So what can I factor out of everything? I can factor out a 3x cubed, right? Because all of these have at least an x cubed in it. So what I'm going to do is I'm going to write 3x cubed. When I divide 3x to the 5th by 3x cubed, I get x squared. 18x to the 4th divided by 3x cubed gives me a 6x. And then 27x cubed divided by 3x cubed is just a plus 9. Okay. So this guy kind of just hangs out. We don't get rid of it. He just hangs out in front. Okay. And then I factor this guy. Well, what multiplies to 9 and adds to 6? 3. X plus 3. X plus 3. And remember, I set both of these, everything equal to 0. So 3x cubed equals 0. X plus 3 equals 0. Since these are the same, I'm only going to write it one time. So if 3x cubed equals 0, then x equals 0, and then minus 3. So x equals 0 and negative 3. Okay, so that's kind of the same when you have polynomials. Okay. All right, the second method is a little bit more involved. This is called the rational root theorem. And what you're going to do with the rational root theorem is you're going to divide two things. You're going to take the factors of the constant, which in this equation would be the negative 6. You're going to divide those by the factors of the leading coefficient. Let me abbreviate, which is this guy. Okay? So here's how we're going to do that. We're going to go factors of 6. It's really negative 6, but we're all going to do the same thing. It's going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. All the factors of 6. Okay? And then we're going to find the factors of 4. It's going to be plus or minus 1, plus or minus 2, and plus or minus 4. So we're going to take all combinations of the factors of 6 divided by the factors of 4. These are all your possible rational roots. So we're going to make a list of the possible roots. So plus or minus all of these numbers we're going to put inside here. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 6 divided by 1 is 6. Now we're going to go the other way. 1 divided by 2 is 1/2. 2 divided by 2 is 1, but we already have that. Okay. 3 divided by 1, or 3 divided by 2 is 3/2. And then 6 divided by 2 is 3. We already have that. Okay. There we go. 1 divided by 4 is 1/4. 2 divided by 4 is 1/2. We already have that. 3 divided by 4. And then 6 divided by 4, which is also the same as 3/2. So we already have that. So those are all the possible rational roots. Okay. So now what we're going to do is we're going to graph the equation, because what you could end up doing is, and this is going to take forever, so I'm not going to do this. You can go through and use synthetic division to test every single one of these points, and it would take you a really, really, really long time, because really you have 2, 4, 6, 8, 10, 12, 14, 16 possible roots, because you have plus and minus each of these. You would do synthetic division 16 times, and I don't think you want to do that. So a way to make it easier is you're going to use a graphing calculator. Let me clear my graphing calculator. So what you're going to do is you're going to just plug this in to the calculator. All right, minus 6. And then you're just going to graph. All right, so now you can look at your graph and say, well, it looks like it crosses here, 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 and here. This is going to give you a good idea of which of these 16 roots to use, okay? So we can look at our graph and see that, well, it looks like it crosses right at positive 2. So positive 2 looks like a good estimate. So we're going to write, it looks like 2. And then, is there a possible other one that we can look for and see? Well, that one looks like, I don't really know what that one is. 1, 2, 3, and something. I don't know. So let's see, negative 3/4. It looks like negative 3/4 might be a good root to check. So if we can get rid of 2 roots right away, it's going to make our life a lot easier. Okay? And how we check those roots is we use synthetic division. Okay, so synthetic division is how we're going to check them. So we put our root that we want to check over here, and we write our coefficients: 4, negative 21, 18, 19, negative 6. And then we just use synthetic division, and if we get a remainder of 0, then that is a root. Okay, so 4 times negative 3 is negative 12, divided by 4 is negative 3. Negative 21 minus 3 is negative 24. Negative 24 divided by 4 is negative 6. Negative 6 times negative 3 is a positive 18. Those added together give me 36. 36 divided by 4 is 9. 9 times negative 3 is negative 27. Add those together, I get negative 8. Negative 8 divided by 4 is negative 2. Negative 2 times negative 3 is a positive 6. And I get a remainder of 0. Yes, that one is a root. Okay, now to use 2. We're not going to do this same thing over again. We're just going to use this guy here. We're going to check 2 using our leftovers. So 4, negative 24, 36, negative 8. We're going to check 2. We're just going to do the same thing. 4 times 2 is 8. Negative 24 plus 8. Oh wait, not negative 24. Yeah, negative 24 plus 8 is negative 16. Negative 16 times 2 is negative 32. 4 times 2 is 8. Yes, that one works. So let me move this over so you can see. Okay, all right. So now we're left with a quadratic, 4x squared minus 16x plus 4. Okay, 4x squared minus 16x plus 4 equals 0. I'm going to divide everything by 4. Okay. Now, equals 0. I'm going to use the quadratic formula to find all the zeros of this, and then that will give you all of the roots. So your roots for this whole big polynomial, and we'll do this together in class so that you can get a better idea, because this is kind of messy, and it's kind of a big concept, so we're going to do this together in class. I just wanted you to watch this video and make sure you have some exposure to the rational root theorem and how we can use synthetic division to check for roots. Okay, so this is a root, and then using the quadratic formula, we'll find the other two roots. Okay? All right, in the next video, I'm going to talk about multiplicity.